Hi everyone, Senan on this side, and now we are on to my favorite sorting algorithm, which is the merge sort. And this is one of the best sorting algorithm or the most famous sorting algorithm that you would find, right? And the best part is it runs in n log n time complexity, and that is why this is more or less preferred sorting algorithm. Okay, so what this is doing is it is using something, a concept known as divide and conquer, right? Divide and rule, divide and conquer. We just check the spelling of conquer, I don't know. Okay, anyways, so what this is doing, so it takes an array, right? What it says is we divide this array into two pieces, right? Piece 1 and piece 2. And what we say is, okay, I again call the same algorithm and I say merge sort this array, and I again call the merge sort and I say you solve this array. Now when you do this, what you would have is two sorted arrays, basically sorted array 1 and sorted array 2. And now what we do is merge these two sorted array into a single sorted array. So that is the whole idea. You may not basically understand each and everything till the time we actually do some sort of dry run or a trial version. So let's randomly initialize let's say an array of, let's say, 6 elements, right? So let's take this and let's initialize it with some values, random values. Let's say 87, 3, 40, minus 10, 20, let's say, and one more number. Let's take 61. Now we have this array. This is obviously not sorted. The largest element is at the first position, the smallest element is at the fourth position, and this is not exactly what we consider as sorted. So what I say is break this into two parts, right? So let's break them into two parts, and let's denote this with arrows with pink. And so what we have is the array with size 3, so 87, 3 and 40, and again we would have three elements on the right, minus 10, 20 and 61. Now what we do is we again break this into two. Now since the length is odd, you can either divide it like this or you can divide it okay, so either you can divide this, so you have this and this, or what you can do is you can divide it like this, so you have one piece this and one piece this. Depending on the implementation, either would work fine. So okay, so what we get is, let's divide it like this, right? So what I do is we have 87 and 3 and we have 40. Similarly on the right hand side we do the same thing. So what we get is minus 10 and 20, and here we get as 61. Okay, this is fine. Now can we actually break a single element? Basically we don't break this single element because we consider this in itself is a sorted array, this in itself is a sorted array, this might not be, this might not be. If you see, this is actually sorted, but it won't always be the case, and as here this is unsorted, right? So what we do is we break this into two, and what we get is 87, 3 we leave 40 as it is because it's already sorted array. We know that for sure. Now what we do is we take -10 here and 20 here, and we leave 61 as it is. Now if you see, we have all the single elements, right? So in a way, if you know recursion, this is what is known as the base case, right? I assume you know recursion, so that is the prerequisite for watching this video. I should have mentioned this before, but anyways, now we have to join back these elements, right? So how do we join 87 and 3? We join it in a way that the resultant array is a sorted array. So we get 3 and 87, right? Now similarly, we join these two to get -10 and 20, although the order did not change from here to here. But let's say if 20 were here and -10 were here, this would be in the sorted manner, right? Now in the next step, what I basically do is I take this and I take this array, right, and I sort this, or I merge these two arrays into a sorted array. So what I would get is 3, 40 and 87. Similarly, on the right hand side, what we do is I combine these two to actually get this array, which is, so in the sorted fashion, it would be -10, 20 and 61. So the order remains same after sorting, because initially after breaking this was already sorted. Now finally, what we do is we actually combine these, or we merge these two sorted arrays. So the resultant array would be what? Of 6 elements. So -10, 3, 20, 40, 61, 87, and this is our final answer, right? This is in the sorted fashion. So basically what we do is, basically the logic is, we take the array, we break this into two array, and recursively call the merge sort on the smaller arrays. Okay, so we call merge sort on this, merge sort on this, and we assume this function is working properly. So we get this array and this array, and we call a merging operation so that we can merge two sorted arrays into a single sorted array. So that is the whole point, right? Okay, so what should I do? So let's write the pseudocode. So pseudocode. Okay, so how would you write the pseudocode? Let's say function, and I call this merge sort, and it takes an array. Now what I do is, okay, so when we are dividing this array, we are not technically dividing this, we are not actually breaking the array into two, but we are hypothetically carrying the indexes or indices of the starting and the endpoints in a way that would keep track of the sortedness of an array. So what I do is I count n, which is array dot size, right? Or let's say we what we can do is, rather than this, we can take the starting index, starting index, and the ending index, start and end. So what I do is I calculate the mid value. A mid would be what? Start plus end and all over 2, right? We get mid. And what I say that, okay, merge sort, I assume you are functioning correctly. And one more thing before that, or we'll see this that part later. Okay, I assume that merge sort is working correctly. So I say, okay, merge sort, what you do is take this array and sort from starting till mid, right? And you give me the array after sorting the array from start to mid. And I call again the merge sort, and I say, listen merge sort, take this array again, and rather than from start to mid, take mid plus 1 and sort it till the end. So technically, after reaching till this point, what we would be having is these two arrays separately sorted. Now what I do is I say, okay, merge sort, now merge these two sorted arrays into one. And merge would take the array, the start point, the mid, and the end. And in the end, I would return the array. Okay, that is good. Okay, so whenever you call merge sort, you take the mid index, you divide hypothetically you divide the array into two. You call this merge sort on the first half and on the second half and assume that it is working correctly. So it would sort the first half of the array, this would sort the second half of the array, and in the end you would merge these two sorted arrays together, and you then in the end return the array. But there is one of the most important thing in any recursive function is there should be a base case, right? So when do I know that I don't need to sort anymore, right? So I say if start is greater than equal to end, you just return. This means if start and end, if they are equal, that means they are pointing at the same element. That means the array is of size 1, right? If array is of size 1, that means array is already sorted. So then we don't have to calculate the mid and divide it into 2. We are already done, right? Otherwise, what you do is, if start is greater than end, that means there are no elements in the array. Basically, that is the whole point. Even if you do start equal to end, I think that would also work. Now this is the pseudocode, and if you see, the only thing we are not sure is how to perform this merge operation, right? Now how do we perform this merge operation? Let's take two examples, right? And for this I would take a very neat example, and I would say 1 3 5 and 2 4 6, right? So while sorting, let's call this as array, and we will call merge. So the function call would be, so this is, since 0 based indexing, 0 1 2 3 4 and 5. So 5 plus 0 by 2 is what? 2.5, but when we store into integer, it will be 2. So this is the mid value, right? So what we would be passing into this function is the array itself. The start is 0, the mid is what? Mid is 2 and the end is 5. Now we have to perform this merging function. So let's see the logic, and then after that we will write the code. Okay, so I'll just copy this, and I'll just paste this, and let's initialize some iterators. So start mid, and let's say end. Now I would say, let's say I is equal to start, j is equal to mid plus 1, right? I take two iterators or two pointers, and I'll call this as I will point here and j would point here. Okay, now I would do is I would take another array, right? A spare array of the same size. And what I would do is, first of all, I'll check is one smaller or two smaller. Obviously one is smaller, so I would take this one and write at this position. Obviously you can use a k pointer here. So since I've added this one here, what I would do is I'll take this I, I'll move it one step ahead, right? Okay, so I'll move this one step ahead, and similarly I'll take this k and move this one place ahead. Now what I do is I compare elements at I and j, which is smaller, j is smaller, right? So I would take the value of the element at j, and what I would do is I'll place the value at the position k, and after doing this I'll take this j, I'll move it one step ahead. Similarly I'll take this k, I'll move this one step ahead. Now again what I would do is I compare 3 smaller or okay, so element at 3 is smaller or element at 4 is smaller. So obviously element at okay, so element at I is smaller or element at j is smaller. So element at I is smaller, so I place this value at the kth position. So k goes here, so 3 is here. Now what I have to do is I to take this I, move this one step ahead. I'll take this k, move it one step ahead, and now I would compare is this smaller or this smaller. Obviously 4 is smaller, so what I would do is place the value 4 at this position. Now I take this and place it here. I take the k and place it here, and again I would compare which is smaller, this is smaller or this is smaller, element at I or element at j. So clearly element at I is smaller, so I'll take this value and place here. Okay, so what I would do is take this file, place this here, and I would move this I one step ahead. So since now my I crosses mid, right? So I'll stop this iteration, and if you see j, we still have one element remaining. So I'll take the all, let's say if there was 7 as well here, and there were, let's say if this is this and 7 is here, and there were more space here, so I would take all the elements at j and after j till the end, and I'll just copy and place this here. So that is the whole point of this merging algorithm. I hope you basically get the idea. Like we keep two iterators, two pointer approach, we keep two iterators, we compare whichever is smaller, we place it in the array, and in the end what I would do is take all the elements and copy it back to the original array. So and we place everything back. Okay, so let's just write this algorithm. So how do we do that? So void merge, and this would take array, the start, the mid, the end, right? And what I would say is I is equal to start, j is equal to mid plus 1. Now I initialize a temp array of size what? Size of let's say size would be end minus start plus 1. Just check this. This would be the number of elements in our temporary array. And what I do is I take k as 0. Right? Now what I do is basically do the same process. So for this I would be writing a while loop. While what? I is less than equal to mid and j is less than equal to, okay, so where is the eraser? J is less than equal to end. What I do is check if array of I is less than array of j, right? So what do I do? If array of I is smaller, then I would say temp of k is equal to array of I. That is what I would do. And then I would do k plus plus, increase the value of k, and do I plus plus, and then continue. Otherwise, if that is not true, if array of j is less than array of I or maybe equal to array of I, otherwise what I do is temp of k would be equal to what? Array of j, and I would do k plus plus and j plus plus. Obviously you can write this plus plus in the argument itself, like at this position plus plus and plus plus. If you're using C++, you can do that, but for the sake of this code we don't do anything, right? In the end, what would happen is either one of the conditions would fail. Obviously these both cannot fail at the exact same time. So what I do is I'll check another while loop, and this while loop would be outside this bigger while loop. So after this while loop we have another while loop. While j, or let's say we do it I is less than equal to mid, what I say is array of k, or sorry, temp of k is equal to array of I and k plus plus I plus plus. Similarly, we do the same thing for the other one. While j is less than equal to end, we do temp of k is equal to array of j and then k plus plus and j plus plus. This is what we are going to do. Now after sorting this, we would have the sorted array in this temp array, right? Now we have to copy this value back to the original array. Okay, so how are we going to do that? Again, we are going to use something similar, or maybe we can use a for loop, right? Let's do it with for loop. For I is equal to start, and so that I less than equal to end, and say I plus plus, and let's define can we do this without, okay, no, this should work. So array of I is equal to temp of I minus start, and this would do the job. Fine. So initially when I is start, I minus start is 0, and I is start plus 1 means the second index in this array from the start, we would be at position 1, and this would do the job, and we just end our merge function here. Now let's discuss, this was the whole code. Basically this was merging, and this was for merge sort is small. Merge sorting is a very small function. The only confusion would be in writing the merge algorithm, right? So what do we do? So let's discuss the time complexity, right? What would be the time complexity? So as I initially said, it is n log n, but how do we actually get that, right? So to do that, we would be looking at the tree itself, and I'll try to explain it as best as I could, but okay. So how much work does it take to sort these elements, right? So breaking won't be taking any time, right? Because we are just calculating the mid and calling the recursive function. So how much at each level, how much are you doing the work? So for okay, so till this point of time we are just breaking elements, but if you observe at this position, right, at this position, okay, so we have, so in this case we have broken all the elements, and now by this we are merging all. So for merging, it takes big O of n time. Again, big O of n, big O of n, and after this we reach the sorted array. So while merging, okay, so this is a very small example. Let's say we have, let me again explain in a better manner. Let's say we have 32 elements, right? We divide this into 2, 16th element, right? 16. I divide this into 2 of size 8, 8, again 8, and 8, and this would be 4, 4, 4, 4, 4, 4, 4, 4, then 2, 2, and then 1, 1. Okay, so basically we are dividing this elements. Okay, now so there are exactly 32 elements in this, and breaking actually won't take any time. So what is this? So to sort these elements together, okay, so these two elements together, these two elements, these two elements, these two elements, we are doing the merge operation for 2 elements for all these 2 pairs, right? So that is taking 32 big O of 32, right? Big O of n. Again, at the height 2, we are sorting, we are using the merge operation for 2 size elements, and if you do compare all of them, again we have to do big O of n operation. Now when we have 4 elements, we again, for sorting, we use, for sorting all these elements, we again are taking big O of n, for this big O of n, again for this big O of n, until the time we reach back to the sorted array. Fine. So we are dividing and then conquering, but we did big O of n 1 time, 2 time, okay, sorry, 1 time for the base, 2 time, 3 time, 4 time, and 5 time. So if you observe, we did big O of n operation, or big O of 32 operation 5 times. right? So if you observe, if rather than 32 we use n, so big O of n operation we do log n times. So log base, okay, so log base to 32 is 5, right? So that is what we are trying to do. Maybe the explanation is not that good, but the algorithm would take big O of n log n time. If you're not satisfied with this, you could also use this logic. What do we say? The Master's theorem also, although Master's theorem also works on this logic, which I maybe failed to explain, but this goes like this. So the time complexity of merge sort algorithm is 2 times time complexity of solving the half subproblem, and that too twice, and plus we do a merging operation of big O of n, right? So after that, if you compare this with the standard form, t of n is equal to a t of n by b and plus order of n to the power d. This is one of the standard form. So what we do is we see log to the base ba, which is what? Log to the base 2 is actually 1, and this is equal to d in this case. So d is 1 in this case, n to the power 1. So in that case, what happens is the answer would be big O of n to the power log base ba, or basically, since both are equal, n to the power d log n, and since d is 1, this is of the order n log n. This is the time complexity. In brief, let's discuss the space complexity. So for merging, we are using a separate array of size whatever the n, right? At each level we are using a size n, and for this function, at max the stack space would be considering log n of recursive calls in the recursion stack space. So in totality, your space complexity would be, so space complexity would be basically big O of n for the temporary array that you always create, plus a rare case of, like, when you call it till the base case, you would have a log n stack space. So this is the time space complexity, and you can ignore this term. So you have space complexity of order n and time complexity of order n log n. I know I have not done a very good job in this video, but I'm still learning how to teach. I know this topic, I have used this multiple times. I'm just learning how to teach. So thank you if you watched till here, but I'll do better next time. So yep, that's the video. Share it with someone you think would learn something from this video, and bye.